All right, the first of the three methods that we're going to go over is by factoring. And here are your steps to solve a quadratic equation by factoring. First thing you need to do is put the equation into standard form, which means your x squared, your x, and even your constants all to one side. It equals 0 on the other side. The second thing we need to do is factor out the GCF if there is one. So that's what we're writing in here, GCF. And I wanted us to write that in because that is the most commonly missed steps. It's not always necessary, but it does always help. So please remember, after standard form, we're going to GCF. Then step 3 is to factor. And then step 4 is to use the zero factor property to solve. Now, example 1 says use factoring to solve the quadratic equations, and I have 8 examples here. I have broken this down into what I call the 4 different types of quadratic equations to factor. Type 1 is a binomial where I have no c term. So you can see from this right here, we just have the ax squared plus bx, but no c here. So no constant. The second type is also a binomial, and it's called the difference of squares, and it's now where I have no b term. So from this here, we have no b, it is just the ax squared, and then it does need to be a minus c. The third type is what I call an easy trinomial, where your a is 1, so you just have x squared instead of ax squared plus bx plus c. And the third one is called hard, and it's not really hard, but it does have more steps. And so it's when a doesn't equal 1, so now we have a full quadratic here of your ax squared plus bx plus c. I'm going to split this video into your 2 binomials will be in this video, and then in the next video will be our 2 trinomials. So going over the first binomial where I have no c term, following these steps here, the first thing I want to do is this into standard form? Well, yes, because it equals 0, so that's good. So the next thing we need to do is factor out the GCF. So what is the biggest common factor that, in this case, both of these 2 terms have? And that is an x. So when I factor out an x, you need to think about this as dividing that GCF out of both of those terms. So that GCF comes outside. X squared divided by x is x, and negative 7x divided by x is negative 7. What we're doing here is we're undistributing, because if I was to distribute this x back in, I get to the original. X times x is x squared. X times negative 7 is negative 7x. So I am undoing the distributive property. For these types here, taking out the GCF is factoring. I can tell that this is factored because I have no x squared term. When you have only your x's as x to the first, there's nothing else you can do to factor. So now I'm going to apply this zero factor property, which says each of these multiples take separately to set equal to 0 and solve. So this very first one is just simply x equals 0. So we're done there. The second one we get is x minus 7 equals 0. Add that 7 over, and we get x equals 7. More times than not, when we have a quadratic, we're going to get 2 different answers. It is sometimes possible to get 2 of the same answer, but more times than not, it's going to be 2 different ones. And I know I'm going to get 2 different answers because it's an x squared. Whatever that highest exponent is tells me how many answers I'm going to get. So when we go to an x cubed, we'll have 3 answers. When I go to an x to the 4th, we could have 4 answers. Whatever that exponent is tells me how many I have. Now, if I pull this up on my graph, I want to show you graphically what we have just solved for. So if I type this equation in and I graph this, what we have found are x-intercepts. That's where this is crossing the x-axis. So it's crossing right here at 0 and then also right here at 7. So you can always check your answers by putting it in your graph and seeing, did you get your x-intercepts right? Okay, on B, if I'm following my instructions, the first thing I need to do is get it into standard form, which means it needs to equal 0. So this does not equal 0 because I have an x on both sides. So we're going to move this negative 8x over. Typically, you want your x squared to remain positive. So I'm going to add 8x over, and that will cancel over there. Now, these are not like terms. Yes, they both have an x, but one's an x squared and one's an x. So this just goes side by side. This is 4x squared plus 8x, and now it equals 0. Second step is to factor out that GCF. So what number can I divide out of both of these two terms? I can divide both of those terms by a 4. And they both have at least one x. This one has 2 x's, this one has 1, so I can take out an x of both. So that GCF goes on the outside. And now what do we have left when I divide both of those terms by that GCF? So 4x squared divided by 4x is x, and 8x over 4x is 2. Okay, again, we can distribute that back and check our answers. 4x times x is 4x squared, and 4x times 2 is 8x. So on these type here, and only this type 1, your binomials with no c, when I take out that GCF, that is also factoring, because now my x's are x to the first. So once I have everything as x to the first, it's not possible to factor anymore. So now we're on to zero factor property. Zero factor property states take each of these multiples and set them equal to 0 and solve them individually. So we have 4x equals 0. Divide both sides by 4, and we get x equals 0. Sorry, I had to pause for a second. I wasn't thinking I was recording. I thought I had to do it all over again. Okay, we're good. So now the second one here, we have x plus 2 equals 0. Subtract your 2 over, and we get x equals -2. So this is always really quick to check on your graph. If I put this in, you have to put it in where everything's on one side of the equation. So I'm going to do 4x squared plus 8x. And you can see from our graph right here, it is crossing at -2 and at 0. Okay, let's go to the next page, and we're going to do our next set of binomials. And I also want to show you something before we actually start solving this. So I want you to understand what we're doing when we are factoring. When I'm factoring this type here, I am basically undoing the distributive property when I take out that GCF. When you undo that distributive property, that is factored. For the rest of these, what we are doing is we are undoing a FOIL problem. So for example, if I had binomials, let's say x plus 2, x minus 5, we would have to FOIL this, right? So we would have x times x for my first, which is x squared, x times -5, which is -5x. My inner is 2 times x, and my last is -10. We would combine our like terms to get x squared minus 3x minus 10. What I'm doing for types 2, 3, and 4 is I am starting here at my quadratic, and I now need to work backwards and get it back up here to my 2 binomials. So this is multiplying, this is FOILing. FOILing is this way. What I am doing is going backwards here to now factor. Okay, so that's kind of the goal of what we're doing. So in this problem here, My second type of binomial is called a difference of square when I have no b term. So we just have ax squared minus c equals 0. So if I'm following these same instructions here, first thing I need to do is put this into standard form, which means it needs to equal 0, and it does. Next thing we need to do is factor out a GCF. Is there anything I can divide into both of these terms that are the same? And the answer is no. I can't divide 49 by 4 or by 2. They don't have an x. This one has 2 x's, but this one has not. So I have no GCF. And so that's okay. We move on to the next one, which is factoring. When we factor difference of squares, all we need to do is take the square root of both of these sides. The square root of 4x squared is 2x. So that's my first terms in both of these binomials. The square root of 49 is 7. So 7 goes as the second term in both of these. And to get to a negative 49, we would have to do 1 plus and 1 minus. When we have a difference of squares, it will always be a minus c right here, and then it will always be plus and minus. If I was to multiply this out, I want to show you where this middle term went. So my first is 2x times 2x, give me 4x squared. My outer would give me negative 14x. My inner is 14x. And my last is negative 49. When I combine my like terms here, those are going to cancel, and I'm left with 4x squared minus 49. So because it's 1 plus and 1 minus, we get those middle terms to cancel out right there. So going back to my steps, we have now factored because everything just has an x. And so now use the 0 factor property. I'm going to take each of these multiples and set them equal to 0 and solve them individually. So for my first one here, I'm going to subtract the 7 over and then divide by 2. So we get x equals negative 7 over 2. Do the same thing with this one. We have 2x minus 7 equals 0. We'll add 7 over and then divide by 2. And we get positive 7 over 2. So let's graph it and see if we got our answer right. We have 4x squared minus 49 graph. Now this one's not as easy to just look at the graph and skip the factoring because I can't really tell what those numbers are. But I'm going to check it. So I'm going to hit trace, and then I'm going to type in negative 7 divided by 2 and hit enter. And I do have a y-intercept right here of 0. Do the same thing here, 7 divided by 2, hit enter, and we have a y-intercept of 0. So we have solved for those x-intercepts correctly. Okay, let's now try part D. Okay, here is actually one that is not technically a quadratic. This would be a cubic, right? It's an x cubed. So how many answers could I potentially have? 3. 3 answers. Okay, first step is to solve, or is to put the equation into standard form. So does it equal 0? Yes, it does. So we're good there. Factor out the GCF if there is one. Is there a GCF? Can I divide both of these terms by the same number? And the answer is yes. What can I divide into 125? That's 25. And can I take any variables out? Well, this one has 3 x's. This one has 1. I can take out 1 x from both of them. So this GCF goes on the outside. 100 divided by 25 is 4. X cubed divided by x is x squared. When you divide variables, you subtract the exponent. So 3 minus 1 is 2. Then minus 25x over 25x is a negative 1. Now this time, taking out that GCF, we're not fully factored because I still have an x squared. So I need to keep going. So now we need to factor. I can see that this is a difference of squared because we have an x squared, no b, and a negative c. So I'm going to bring my GCF down. And now I want to take the square root of both of these numbers here. The square root of 4x squared is 2x. The square root of 1 is 1. And for this to be a minus 1, and to cancel out that middle term, we need this to be a positive and a negative. So what are my answers here? We have 25x squared equals 0. Divide by 25, and we get x is 0. Here, I've got 2x plus 1 equals 0. I'm out of room, so I can't really write it all, but I'm going to subtract that 1 and then divide by 2, and we get x equals negative 1/2. And then for this third one here, I'm going to add this 1 and divide by 2 to get x equals 1/2. Does it make sense that we got 3 answers? Yes, because I started with an x cubed. So if I check my original answer and my original problem, where I want to do this, okay. We have 100x cubed minus 25x. I'm going to hit graph. So here's my cubic. We're very scrunched in. I'm actually going to go ahead and just change my window here, just so we can get a better look. There it is. Okay, so no U-shaped parabola anymore because we have an x cubed. It makes a different key graph, right? So if I do trace 0, that one works. Negative 1 divided by 2, y of 0, so that one is correct. And 1 divided by 2, we also get y of 0. So factoring is really important. I'm going to go ahead and stop the video here, and we're going to do the next video going over trinomials. But factoring is really important, not only honestly for this class, we're going to be using it in this class in just about, nah, that might be a little extreme, but a lot of lessons going forward. We have to get good at factoring. But this is something that you're also going to be using in Calc 1, even in Trig. You're going to be using it from here on out. So please take the time to get good at factoring now, and it will make the rest of your math classes so much smoother.